Welcome to Explore Quiz channel. Today we're learning about deep learning, one of the most important ideas behind modern AI systems like image recognition, generative AI, and robotics. We'll go step by step through neural networks, layers, and training, and there will be quizzes along the way to test your understanding. Deep learning is a branch of machine learning built around multi-layered neural networks. These networks are inspired by the brain in the sense that many small units work together to process information. What makes deep learning special is that it can learn very complex relationships from data without us writing every rule manually. That is why it is used in computer vision, generative AI, self-driving cars and robotics. In traditional machine learning, we often define features or rules more directly. In deep learning, the model learns by adjusting weights and biases between connected neurons. Because there are many layers, the network can combine lots of simple mathematical operations into something very flexible. This distributed structure is what gives deep learning so much power and versatility. A useful way to think about this is function fitting. Traditional machine learning may try to capture data using one simpler line or curve, but deep learning can combine many small adjustable pieces to match more complicated shapes. This is why neural networks are called universal approximators in theory. In practice, once a model has at least 4 layers, it is generally considered deep learning. Deep learning models are often trained with supervised learning where examples come with labels. But collecting huge label datasets is expensive and time-consuming, so self-supervised learning became very important, especially for foundation models and generative AI. Another big factor was hardware. GPUs made it possible to process massive computations in parallel. So that covers the basic idea of deep learning, why it is useful, and what made it practical. Now that we've covered deep learning basics, let's test what we've learned so far.
Here's quiz number 1. See if you can get it right.
Question 1. What best describes deep learning? The correct answer is a subset of machine learning. Deep learning is a branch of machine learning that uses multi-layered neural networks to learn from data. Question 2. What mainly gives deep learning its flexibility? The correct answer is many adjustable network layers. Deep networks combine many small mathematical operations across layers, making them highly flexible. Question 3. Why were GPUs important for deep learning growth? The correct answer is they enabled parallel computation. GPUs can handle many computations at once, which greatly speeds up deep learning training and inference. A neural network can be thought of as a chain of mathematical operations. Each artificial neuron takes input, applies an activation function, and passes its result forward. Together, all these operations map an input to an output. By adjusting the parameters, the model changes how that mapping behaves and improves its predictions over time. Neural networks are organized into input, hidden, and output layers. The hidden layers are where most of the learning happens because they build internal representations of the data. Earlier layers may detect broad patterns, while deeper layers capture more specific and detailed features. This layered hierarchy is one of the main reasons deep learning works so well on complex tasks. Every connection between neurons has a weight that controls influence, and each neuron usually also has a bias term. The neuron processes a weighted sum of inputs and then applies a non-linear activation function. That non-linearity is very important, because without it, the network would behave like a much simpler linear model. These weights and biases are the parameters the network learns during training. When the model makes a prediction, it performs a forward pass. Input data enters the network as a vector of features, and each layer transforms that data step by step until it reaches the output layer. In classification tasks, the output may be converted into probabilities for different categories. Now that we understand the structure of a deep neural network, we have a complete picture of how inputs become predictions. Now that we've covered network structure, let's test what we've learned so far.
Here's quiz number 2. See if you can get it right.
Question 1. Where does most of the learning happen in a deep neural network? The correct answer is in the hidden layers. Hidden layers build internal representations and learn the patterns that help the network make good predictions. Question 2. Why are nonlinear activation functions important? The correct answer is, they help model complex patterns. Nonlinearity allows the network to capture complex relationships that linear models cannot represent well. Question 3. What happens during a forward pass? The correct answer is, data moves layer by layer to prediction. In a forward pass, the input is transformed through successive layers until the network produces an output. Training a deep network is difficult because there can be thousands, millions, or even billions of parameters. Each one contributes in some way to the model's final error, so manually figuring out how to adjust them is simply not practical. The overall goal is to reduce loss, which measures how far predictions are from the correct answers. To do that efficiently, deep learning relies on specialized optimization algorithms. Backpropagation means sending error information backward through the network after a forward pass. Starting from the loss function, it uses the chain rule of calculus to determine how much each weight and bias contributed to that error. The result is a set of gradients, which tell us the direction each parameter should move to reduce loss. This makes training large networks mathematically manageable. Once gradients are calculated, gradient descent uses them to update the parameters. In simple terms, it nudges weights and biases in the direction that lowers the loss. This process repeats again and again across batches of training data, gradually improving the model's predictions. So that completes the core training story: forward pass, loss, backpropagation, and gradient descent. Now that we've covered training process, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. What is the main goal of training a deep neural network? The correct answer is, reduce the model's prediction loss. Training aims to make predictions more accurate by lowering the loss between predicted and true outputs. Question 2. What does backpropagation calculate? The correct answer is, how parameters affect the loss. Backpropagation computes gradients that show how each weight and bias influences the loss. Question 3. What does gradient descent do with gradients? The correct answer is, updates parameters toward lower loss. Gradient descent uses gradient information to adjust model parameters so the loss decreases over time. So today you learned the foundations of deep learning, from neural network structure to the training process that makes these models improve. Hope you did well on the quizzes and got a stronger understanding of how modern AI systems work. If you enjoyed this, like, share and subscribe to Explaquiz channel for more interactive learning videos.